Many of us spend a lot of time reading and writing email. It's an important part of our lives, and I sometimes find I take for granted how interesting and useful email is as a communication mechanism. Despite its ubiquity, the experience of email as a product hasn't changed in a long while. We've seen incremental updates and features, but it hasn't felt like anyone is really innovating. My guest today, Andrew Lee, has spent a lot of time thinking about email and communication. After a very successful run with his previous company, Firebase, one of the most popular app development platforms in the world, he's assembled a team to deliver the product experience that email deserves. And if you haven't guessed this already, that experience involves AI. When you use the Shortwave email app, everything you write is going to go through at least one LLM. This might sound like a lot, but I find Shortwave's approach to what LLMs can do and building systems with them incredibly thoughtful. And if you want to know why I think that, you'll just have to keep listening. This is the Gradient Podcast. I'm Daniel Bashir. Here's where I tell you to do all the things about subscribing and following us in all the various places that you're able to follow us. Instead of filling this time with sponsorship ads, I'll just ask you to leave me a rating, to share this with your friends, and anything else you'd like to do. It helps me a lot. Thanks. But now, without further ado, Andrew Lee. Andrew, right now you're building really a startup that is trying to pioneer, I guess, a pretty interesting take on an email client. And I want to build our way to Shortwave maybe by talking about a couple of the things you've done along the way. So this is not your first rodeo. Going back a little bit, I want to talk a bit about how Firebase came about, because that was also not your first rodeo. You and your co-founders had worked on a couple of things before that led you to pivot to what ultimately became Firebase. So I'd love to go through a little bit of that story.
Yeah, it's been quite a journey. Definitely not my first rodeo. I actually started doing startup things in 2007. I had a real job at one point doing embedded systems software, and decided I wanted to do the startup thing, and started working with actually a high school friend of mine. Way back in 2007, I quit my job and started on this road, and we tried a whole bunch of stuff that failed. For about 3 years, we were kind of sort of stumbling around in the dark, trying different things and falling flat in our faces. And interestingly enough, we kind of, throughout that process, we kept stumbling around like different types of communication software. So to some extent, Shortwave feels like I'm coming back home and I'm finally building the thing that I want to build, which is communication software. But the way we got to Firebase is we built a thing, we pivoted when it didn't work, we built a thing, we pivoted when it didn't work. And each time we learned something about ourselves or the market that informed the next product. And the thing that eventually pivoted into Firebase was that we had built a chat product. And it allowed you basically to have like a Facebook Messenger style thing on your website back when real-time chat in the web was new and exciting and hard to build. And we built this, and people used it and they liked it. But when we went and talked to them and said, hey, why do you like this? They said, well, there's nothing about the UX. We don't actually like your product, but it's really hard for us to build this ourselves. And, we need to build this thing in our app product, and this is the best that we can do. But hey, it would be great if you guys just threw out your whole UI, gave us direct access to the APIs in the backend, and let us build our own stuff. And so we said, sure, let's try that. And we ripped out the front end and we redesigned the back end to be really more of a generic API, and we gave that to people, and that turned into Firebase. And I think one of the really interesting things about that, which I think is going to come into play when we talk about Shortwave, was we were not database people. We had no particular expertise in databases. We had no particular expertise in building developer products, other than the fact that we were developers ourselves. But I think that naivety led us to be willing to try to build something very, very focused on what customers wanted without knowing what the pitfalls of that would be, and let us, innovate and do some new interesting things.
I could definitely see this sort of business, like what you built for Firebase, having played out differently. As you're saying, had you come in with prior experience, maybe developing backend systems. And I guess it's hard to evaluate counterfactuals and what that can all look like given that you had the experience you had. But I'm really curious if you have any thoughts on the ways in which Firebase was, particular ways in which it was maybe different, maybe better than what you would have gotten to had you been coming into this with some preconceived notions of what the sort of business, what the sort of product should look like.
Yeah, absolutely. And I think the biggest thing we were naive about was how to scale a system like we had. So basically, we went out at the beginning of Firebase when we were pivoting and said, "Hey, we have failed so epically so many times because we thought we knew best. This time around, we're going to assume we know nothing. We're just going to ask a whole bunch of users what they want, and we're going to try to build that thing as best we can to exactly what they describe." And we went out and had those conversations, and all of our users said, "Hey, wouldn't it be really nice if when I, made a change, that change propagated to everybody else immediately, right? Like speed of light fast. And wouldn't it be nice if when I made two writes into the database that they would like show up on everyone else's clients in the same order consistently, right? And wouldn't it be nice?" And there were all of these different constraints that they wanted to have. And we're like, "Yeah, that's good, and that's good, and that's good, and that's good. We should do all of these things. It should be like super fast and super consistent and all of these other things." And at the time, we didn't, I didn't know what the cap theorem was. I didn't know that a lot of these constraints were like fundamentally trading off against each other. And I think had I known more, I would have been like, "Oh, we can never build all this stuff." But I didn't. And so we tried. We said, "Okay, we're going to build all this stuff and we're going to make it like super consistent. We're going to make it super fast. And we're going to make it super easy to use." And what we discovered was, yes, there are fundamental trade-offs, but actually the underlying technology that was powering this stuff was getting better and better to the point where like the ceiling on a lot of that stuff was a lot higher than it used to be. And you could actually get pretty far without trading those things off. So as an example, like SSDs had just come out at that time. And so a lot of what people expected in terms of your like ability to be performant and scale under these constraints changed dramatically when you went from a spinning disk to an SSD. And so, despite the fact that, we had made some fundamentally bad trade-offs, we were still able to make it pretty fast and scale pretty far under those conditions. And I think we learned that if you build a thing that users want and you can afford to invest in over the long time period, you can push down, the N on a lot of these different constraints, like pretty far. You can't fundamentally change the scaling properties of the systems, but you can make them scale pretty far if you're willing to like really invest.
The cap theorem is an interesting thing to call out because I think that this is something we see in ML as well when it comes to there are many theoretical frameworks about what is and isn't possible, but often, of course, those do restrict things in really key settings, I think, and when you go far enough. But when it comes to just the practice of I have a system that I'm actually trying to implement out there in the real world, some of these theorems and things like this only really matter at certain points that you often don't reach in production scenarios, I think. And so it's really kind of inverting this where you're not starting with the assumption of, well, I have to pick one, I have to pick consistency or availability for the system I'm going to build, but you just kind of, as you're saying, do as much as you possibly can. And it seems like things in your particular situation they can kind of work out. And from the user perspective, it all kind of looks the same.
Yeah, actually, what comes to mind when you say that is on the last guest that you had on the podcast, you had a conversation about whether the thing is like actually doing abstract reasoning or whether it's just like spitting out tokens in a way that it's seen in the data. And I think that's a very interesting philosophical discussion. But our team we're not AI researchers. We are building a real world practical application. And for our use case, whether it's actually reasoning or not for many of the things we're doing is kind of irrelevant. If it is able to, choose the right tools when running search, and if it's able to spit out an email that makes sense and get the right answers, then great. We look at this as a tool. If it does the job, that's good enough.
That's a great point. Yeah, I think it's easy to get bogged down into debates over reasoning and consciousness and all these kind of high fluting topics. And I guess part of it is that nobody really agrees on what the definitions of these things are. And in a case like yours, it's like, yes, we're maybe going to use the word reasoning here, and maybe people have different takes on what that means and whether you should be using it to describe what you're describing. But as you just started to lay out, you have a pretty specific sense in which you mean reasoning, and you have a set of things that you would like to do. And so, what you're saying by this can reason is really that I have this set of things that I need to do with my LLM. My LLM is capable of doing those things, and that's the kind of claim you're making.
Yeah, and I can give you an example of this. So when you ask a question in our AI assistant, like if you ask it to like look up a certain kind of email or you ask it to write a reply or something like that, the first step is we try to figure out what data sources we need to access to do that task. And so we have a big prompt that looks at a bunch of things about the layout of the screen and looks at the questions you're answering and tries to figure out what are they trying to ask us to do? Are they trying to ask us to like look at the thread they're reading? Are they trying to ask us to do a search? Are they trying to ask us to like look up their settings? Are they trying to ask us to reference the shortwave documentation? And all we really care about is does it enumerate the right set of things for us to do? And we have a test suite and we have a whole bunch of example cases, and then we we run a unit test every time we modify that prompt or change the model that's underlying it, and we want it to spit out those things. And that test suite is just generated by us. We look at it, we eyeball it, and we're like, what is the user probably trying to do in this case? Okay, they're probably trying to do this. We need to get this set of tools. And yeah, we look at it as just a black box. We want question to come in. We want the set of tools that need to be used to load the data to come out the other end. And however that happens works for us.
Yeah, I think since we're already kind of getting into shortwave a little bit, I think this is maybe a good time for us to pivot the conversation into talking about some of the motivations here. When you sort of describe what shortwave is all about, and you kind of mentioned this as coming back home in terms of wanting to work on communication software. It really feels like you've thought quite a bit about email, given one of the statements you make about it is email is amazing. And I think in this you're probably talking about like the really cool federated infrastructure that's going on and deserves better. And I feel like they're both like simple statements about email, but I feel like they seem to like underlying them, I feel like is a lot of thinking you've done about email, is what I'm guessing. And I'm wondering if you can maybe break that apart. What do you find so amazing about email? Why does it deserve better?
So I've been working with email since the mid '90s. So my dad and I, when I was in high school, we actually ran an ISP in our basement. And back in those days, email wasn't this like weird special case. Email was cutting edge, right? The stuff you could do with email was really cool. We went to France when I was 9 years old, and like we could talk to people back home textually over this amazing thing called email on the internet. It was so cool. So I learned to understand kind of how it worked and learned to appreciate the things it could do then. And obviously it's been in heavy use ever since. And I mentioned with earlier the Firebase, like many of the things we tried were like chat products, other kinds of communication products. So I've always had a passion for communication. I've always had an interest in the federated nature, the technology behind email and how it works. And I see two really big benefits to email over other communication systems. So it is different than every other app that you have on your phone to talking to other people, in that it isn't just one app from one company with one service that's operating it. It is a protocol that we've all agreed to use, and anyone can run a server, and there's many servers and there's many clients. And if I want to talk to you, I just need to know what your email address is. And since we've agreed on, how that information is going to be moved around the internet, it all works magically. And for a user, this does a couple of great things. One is it is universally interoperable. I don't need to get on the same app as you if I want to talk to you. If we have a group of, 5 people and we're trying to coordinate a time for the podcast, like I don't have to be like, all right, let's all go on WhatsApp and we'll start a group thread. Like I just need to know everybody's email address. I put them on the thread and we can all be on our own services, and it works great. The other really great thing you get is a governance benefit of if you're someone who really cares about your privacy, the control of your data, say you're a big multinational corporation, or you're a government, or you're a political activist or something, you have the ability to run your own servers and control that data yourself. And I think that is super important. And the reason actually we started Shortwave was, and I won't go into the whole history of my time off, but I left Google in 2017. We started Shortwave at the beginning of 2020, but in 2019, when I was sort of looking around to figure out what I wanted to do next, a couple things happened. One is Google killed off Inbox, which was their next gen email client. They were trying to iterate on the UX and make it much better, but it became clear that they weren't going to be the ones to kind of push email forward to the next level. But the other thing that happened was I was watching the protests in Hong Kong. There were democracy protests there. And I started to see how centralized services were being used as a means of suppression and control of the protesters there. And the Chinese government was using WhatsApp as a way to monitor what was going on and maybe control that communication. And I said to myself, hey, that's not a good thing. At least this isn't happening in other parts of the world. And then I started paying attention, realizing actually this sort of thing is happening in lots of centralized services all over the world, including in the US and Europe and places you think would know better. And then I said, well, hey, at least we have email. And then I saw Google kill off Inbox and I said, ooh, well, maybe we won't have email forever, right? Maybe if people aren't willing to do the work and invest and make it great, it's going to die a slow death because people aren't thinking about how amazing this federated infrastructure is. And I started to think, maybe I need to do something. Maybe it's time that I made email amazing so that people wanted to use it, so that this federated infrastructure behind it could live on. So that was the motivation. That's why I called up all my Firebase friends and said, hey, let's do a startup.
This is really interesting. Hong Kong is a particularly good counterpoint here. I also follow the protests really closely, and it's interesting having spent a little bit of time in China. I remember seeing the way that WeChat could be used for literally anything you wanted to do. It was not just communications, but you could pay with it. You could do a million other things. And the idea of an everything app is pretty attractive in lots of ways. But exactly to what you're saying, when you have everybody in a country who is relying on this sort of thing, that centralization can definitely breed sorts of misuses, surveillance possibilities, things like that might not be so great. The other thing you mentioned, though, was about in 2019, Google killing Inbox, and really it feels like they're not going to be the ones to build the next generation of email if that is to happen. And as you mentioned, you spent some time inside Google after Firebase got acquired. I'm curious if that insider view gives you any intuitions about why Google doesn't seem to want to innovate on email.
Yeah, I learned a ton from my time there. So so we were acquired in late 2014, and at the time, the only other job I'd had was at a kind of a smaller software company, and I was a very low level employee at the time, and I'd never been in sort of a leadership role inside any sort of large company before, and that was quite an eye-opening experience to see how all of that worked. And Firebase scaled from, at the time of the acquisition, there were 24 of us, to by the time I left, there were hundreds of people in multiple countries and many offices, and it was this whole big thing. And I generally think Google as a big company is run very well. I'm fairly impressed by what I saw, and I thought it did a great job at a lot of things. But there are certain types of things that I think big companies in general, but especially Google, really struggles with systemically. And I got a good intuition for what things I thought it was going to be able to execute really well on, and what areas I thought it would really struggle on. And I think the perfect storm at Google is if you have an existing product, like a legacy, a big existing legacy product that needs to innovate quickly. And at the same time, it is being pulled in multiple different directions by different teams. Different people want different things from it. It is going to be really hard to move quickly, for them to move quickly and deliver something at a high quality level. And specifically in the case of Gmail, it's this massive product. It's been around forever. Not forever, but 20 plus years. Well, not plus, 20-ish years, right? And Google Cloud has ambitions for it, right? It's sort of the linchpin for the Google Workspace suite. The ads org has wishes for it because they want people to log into Gmail. The internal users of it, like the heaviest user of Gmail is Google. They use it a ton. So there's all these different groups that are kind of pulling it in different directions. And if you're a PM on that team and you're trying to innovate this product, you've got a bunch of different stakeholders to take care of. You have a huge existing user base that you don't want to break. And the way Google is set up, the incentive structures around promotion and stuff make it much easier for you to advance your career by starting something new than to drive forward one of these big existing legacy products. And I think the inbox case is a great example of this, where at one point Google said, hey, we need to innovate in email. And they took the best people from the Gmail team and they turned them into this like tiger team to build this new product. And they delivered. They came back with something that was really cool and people really liked. And the result of that was the project got killed off. And a lot of those people left Google. And I actually went and talked to a bunch of these people who had been on that team and talked to them and tried to learn what I could about that project and what went well and what didn't go well. But it became very clear to me that there was so much legacy and there were so many forces pushing on Gmail from different directions that they just weren't going to be able to drive things forward in any one particular direction particularly quickly, and that it wasn't really a place that really ambitious, really smart PMs wanted to be. And I think you could probably see for yourself if you go into Gmail and you look at all the different toolbars they have and all the different sort of related products that are shoved together in the same UI, like they have their rooms and stuff. You could start to get a sense for which PM owns each box on that page, right? You're like, oh, okay, this must be one product manager, and this must be a product manager in another org with a different set of OKRs. And there's like some PM that owns like just the top bar here. And once you've been there, you can kind of spot in the product with like the divisions between groups and teams, and it's all showing up in their product. And I'm convinced that'll continue. I think what's happening with AI right now is, and I don't know if you've played with the Gmail AI features, but there's, I think rapid iteration and progress on the kind of core AI tech at Google. But I don't see the Gmail team like grabbing that with both arms and being like, how are we going to make this amazing for email? They're integrating things here and there, probably because an OKR came down from the top, but like, I'm not seeing anything, any groundswell of like innovation from the Gmail team themselves.
I would agree with that. Definitely as a user, I wouldn't say I've dug into all of the AI features they have available, but it does look like there's not really an overarching product vision here. As you're saying, it's probably like we need to add this sort of feature, and it's more sort of a one by one thing. I want to use that to pivot a little bit into more about Shortwave and kind of the initial things that you were doing with this. So, as you've mentioned, email deserves better. You brought a team of ex-Firebase folks to come together and work on this. And at the beginning, you were chasing this as you had kind of an overarching product view. And eventually you sort of started to bring AI into that picture and saw how useful it was. But that wasn't always the case. And having spent a little bit of time with Shortwave, I can see that you've added a couple of other features and really interesting things that feel like they're kind of obvious additions from like a user of email perspective of things you might want to do. I am wondering, before AI came into the picture, what did that overarching product vision look like?
Yeah, we've actually kind of pivoted twice in Shortwave's history. So when we first started the company, the idea was collaboration. So Firebase was mostly used by teams that wanted to build collaborative applications because of the real-time sync nature of the database products that we have. And we got a really good sense for how powerful collaboration can be in an app and what is possible with collaboration and how to build collaborative features. And we said, hey, we're going to take that and bring that to email. And we built a bunch of cool collaboration features. So you'll notice, like, if you use our app, like, we'll show you who's typing and you can like emoji react and things like that. And that pretty quickly failed. And the reason it failed wasn't so much that the product experience wasn't good. We actually use it that way internally, and it's great. There's some other teams that use it that way. But what failed was a go-to-market thing, which is if you're someone at a company who's looking for a Slack alternative and you find us, you're not looking to go at the same time and convince your whole team to change email clients. You don't want to do that. That's a pain in the butt. So given us or anybody else that is just sort of a separate product, the separate product basically always wins. If you're someone who is looking for a new email client and you come to us and we're like, cool, you should also stop using Slack, you're not interested in doing that either. So people aren't shopping for email client and team collaboration experience at the same time. And we tried again and again to make this pitch, and doing those two things together, even though most people when we talked to said it would be awesome if my team collaboration, my email could be unified in some way, when you actually try to get them, there was no point in time when they actually want to make that sale. So we spent about a year on that, figured out that was kind of hopeless, at least as the initial product. Maybe after we have users on, we can have some features like that. But as initial product, it was hopeless. And then we said, okay, we need to pick a direction. And we said, we're going to focus entirely on the individual email experience. we're going to make it so you, as the only person at your organization using Shortwave, this is going to be the best, most amazing individual email client that we can make. And so we started looking at other things that we could improve to the product and started just saying, how can we bring like modern productivity practices and modern design and like a really fast app to bear on email. And so a lot of things you've probably noticed of like, oh, this is like a nice new addition, like the way they have threads laid out are different, or like they have some cool innovations in the inbox, so they have, done and pin these actions that are like very central to their workflow. That's where all that stuff came from. And I think we actually did a very nice job there. And there's a lot more we want to do on that front as well. But about a year and a half ago, we kind of got the core of that stuff built, and we had what I felt was like a pretty solid email client. It could do the basics. It could display your emails, and you could triage things in your inbox, and you could label things, and you could search, and you could add your signatures, and like all that stuff, which by the way, there's a million things in email. So just getting the basics is like a ton of work. But we'd finally gotten all that stuff done, and we were growing, but we were only growing very slowly. And the problem was like, there's just a lot of good email clients out there. And the value that we were providing to people was not huge. And it was just a really hard sell to go to people and be like, hey, how would you like to like totally change the way you do email and trust, a startup with your email instead for some kind of incremental gains on your productivity and user experience? That was a really tough sell. And at the same time, we saw everything that was going on with LLMs. And we're like, ooh, that's really interesting. We have this amazing corpus of data, and it's all in text that like we can't, through traditional means do anything particularly interesting with. But suddenly there's this tech that could maybe take all of that, blobs of text that we have from our users and do something really useful with it. And we started paying attention to this. And at one point, my old co-founder from Firebase, James, he's one of our advisors here. He came in, he built a Chrome extension on top of Shortwave that like did some stuff. And he's like, hey, look what I built, guys. And it was just like a summarization use case, but we're like, wow, I did not expect it to be this good. Like we hadn't played with it enough to get a sense of like how useful it could be in email. And we dug in and decided, hey, this is the moment, right? These things are finally ready for like real world applications, like what you talked about earlier, like whether you want to call it reasoning or not, they were actually ready to be really useful. Let's go all in. Let's make that our focus. And so we pivoted again and said, hey, we are all about AI, right? We are trying to bring this amazing technology to bear on this crazy corpus of tokens that you call email. And we're going to do everything we can think of to unlock value and productivity for you from those tokens.
And this is manifested in a couple of different things you've built. Perhaps there are a few different things I want to talk about here. And since you mentioned that it's changed so much, perhaps we can talk about the AI assistant last. But there's a couple of different things you've done besides that. So one of them has to do with, and this is, I guess, kind of it factors into part of the AI assistant, but there's an AI search infrastructure your team's worked on in terms of using embeddings and other techniques to kind of answer questions from email history. And this factors into the picture of the mental model of like an assistant living in your inbox where you could ask it questions about what sorts of things do I need to do based off of emails I've gotten and things like this, which can be really useful for somebody who has a lot to do and needs to figure out, I have these 20 different emails that I haven't read or haven't responded to or need to take actions based on. So maybe from both kind of a product experience perspective, but then also getting into it a little bit technically, can you tell me about, in particular, like that search infrastructure and maybe some of the first few AI techniques you brought to bear on email?
Yeah. So I'll start with some of the first features that we did, and then I'll talk about kind of the product vision here and how we built some of that stuff. So the initial thing we did was said, hey, we're really excited about this, but like I said with Firebase, we know nothing. We just got to go talk to some customers and see what they want. And so we're like, we got to build something that we get out there and get real feedback on. And we've got to like update our website to say that we're doing this so that we can get a good sense for like how many people actually care about this. So the very first thing we launched was a summarization feature, simply because it's easy. And this is why you're seeing this in every product out there. It's pretty straightforward to take some text, throw it in an LLM, give it the right prompt, and like turn it into something shorter, and it's useful in a lot of cases. So that was the first thing that we launched. And people loved it. People were excited. We got a bunch of press coverage and a bunch of signups, and everybody came and said, wow, an AI email client. And then most people were pretty disappointed. Like our churn actually got way worse because we had all these people being like, holy crap, you're going to do this cool AI thing. And they came in and they're like, oh, all you have is summarization. Where's the rest of this stuff? And so then we started to think, okay, how do we really take this to the next level? How do we, rather than just shoving open AI in here in a few places, like how do we make this something that's like fundamentally more capable? And there was, I think, a vision that came together of, hey, a lot of people who are heavy emailers, they have a human assistant, right? They have an executive assistant who's in their inbox, who's helping them triage stuff, who's flagging important emails for them, who's like writing drafts for them that they just have to press send on at the end. This is a thing that exists. People pay a lot of money for an executive assistant to help them with their email. Wouldn't it be cool if, rather than that being like 6 digits a year, if that was like $20 a month? And this looks like it's now possible with AI for us to deliver a lot of that value at a price point that like basically everyone could have for their business. And so we started giving this product vision of like, what if it was like a real executive assistant, like someone who was like sitting next to you in the chair, who could see the screen that you're on, who knew what you were doing, who knew all of the history of you and your business and the emails that you've ever sent, and could just help you with things that a human can help you. And we started to say, okay, from a technical perspective, how do we actually build that? And the key piece was, well, they have to know about you, and they have to know about like everything that you might care about. It can't just be a stock LLM that knows what LLMs know. That's all public knowledge. It has to understand you. But fortunately, we have your email. And in your email is, all of the meetings you've ever had. It's all the notifications from your SaaS products. It's every piece of correspondence you ever had. It's every introduction that's ever been made to you or by you. It's everything you need to know. If you're a leader at a business somewhere or a venture capitalist or something, like your email can tell us so much about you and your preferences and your relationships. And we have all that data. We just need to unlock it. And the way to unlock that is with really powerful AI-backed search. And the cool thing about where we were at the time, we sort of lucked into this, but the architecture of the Shortwave app was designed for real-time collaborative experiences. And the way, and it was modeled after a lot of the stuff that we'd learned from Firebase, where it was a client-server architecture with a real-time sync engine that combined client-side resources with server-side resources to build this like cohesive product. And if you want to do AI stuff, that's the way you want to build it, because you want to bring together cloud resources, GPUs, vector databases together with a really nice on-client experience to have the best of both worlds. And we're kind of the only app for Gmail, besides Gmail itself, that's built in a way to do this well. Like all of our competitors pretty much are client-side applications, which it's simpler to build and there's privacy benefits to it and stuff, but it's really hard to like combine that with a vector database and GPUs. And we said, hey, this can be our differentiator. We're going to build really good AI search infrastructure. We're going to take, when you receive an email, we're going to embed that thing. We're going to store it in a vector database. We're going to have a big GPU cluster with a cross encoder so we can like do re-ranking stuff. We're going to make some really good AI search, and we're going to power a ton of stuff off of that. So the vision is like a human sitting next to you in the chair. The core tech that enables that is really smart AI search backed by embeddings and a bunch of GPUs.
One thing I'm thinking about right now that I feel somebody might be wondering at this point is, as you've talked about, there are kind of a couple of things to keep in mind here. One is, again, going back to the initial motivation of all this, with email as having this federated infrastructure, and people really want to have a lot of benefits because of that. There's freedom of expression, privacy is a key benefit, but then at the same time, you want to build the system and you want to make it really fully aware, very aware of the person using email. And that's not for a goal of something like centralization. It's really more to enable this person to do all the things they might want to do with email. But I could imagine somebody thinking about this a little bit and being worried about things like security and all of this. So I'm curious how you think about some of those questions.
Yeah, a couple of thoughts here. The first thought is, I think most of our users don't really care about the decentralization in the abstract, right? It's a cool idea if they think about it, but like they got work to do. They want to get things done. And it really has to be something that we provide over the long term as a side benefit of the core benefit, which is like we help you get things done. And the best example I can draw here is WhatsApp, where they have end-to-end encryption, but like I don't really think that's the main reason people sign up for WhatsApp. I don't think it's the main reason people stay on WhatsApp. They use it because it's simple and fast and everybody's on it. And also it's end encrypted. That's a nice thing to have. So I think we need to do the same thing with what we're doing. And yeah, a common criticism I get is, hey, you're trying to help decentralize the internet, and yet you're building on top of Gmail, and that's not helping at all. And I think that the counterpoint I would have is we have a path to do that in the future. And as long as we are helping the email ecosystem thrive versus some of these centralized services, we are continuing to promote this federated system. And down the road, I would love to have on-prem solutions and open source solutions, and people can run that stuff if they want to. I also would love to have a hosted service that isn't based on Gmail, if people don't want to put their email with Google. But we have to start somewhere. We're a small company, and so where we are focusing right now is trying to deliver real value that you will sign up for, and generate a business around it that we can actually use to fund all the other stuff that we want to do.
This makes a lot of sense. Let's take a little bit of a dive into some of the kind of architectural details for the AI email assistant. And as we talked about a couple of times earlier, the I guess main mental model for this is, again, a personal assistant or an executive assistant that lives in your inbox, that helps you triage things, takes actions. And one of your developers wrote this really great detailed blog post about deep diving into that architecture. And I remember reading this, and then at the very end of it, it's like, oh, and by the way, we've optimized this to answer almost all of your questions within like 3 to 5 seconds. That was really, really cool. Like that's a lot of hard work. So I'm wondering if we could maybe start though with some of the kinds of high level details here, because what you've done with this, you're using techniques like RAG, but you've gone really, your team has gone really beyond the basics, I think, when it comes to these LLM applications. As you said, you're not just trying to shove OpenAI into places, but the team is really like deeply thought through, where are we integrating LLMs? Where are we using other sorts of techniques in here? And so I'd love to talk a little bit about how that kind of came about.
Yeah, absolutely. So I think the thing that people are excited about with our product, and that post has been a very popular post, is it's not so much that we're doing anything that is super novel or like interesting academically. Like we're not researchers. We're not at the cutting edge of what ML can do. But I think it is one of the few systems, at least at the time, which it was only a few months ago, but that actually made this thing work end to end in a real production application, and it actually worked. And so we managed to, through duct tape and lots of cleverness, put the whole thing together and ship a product, and have a product that actually delivers real value. And I think this actually says a lot about our team, and like the way our team is made up. We're a bunch of startup hackers with like data systems experience. We're good at putting these systems together, but we're not AI researchers. Let me walk through kind of at a high level how this thing works. So the main AI feature that we have, for folks that are listening who aren't familiar with our product, we have a conversational bot that you can talk to that can do things like write emails for you and translate the thread you're viewing, and it can also search your entire email history and answer questions from your history. And there's a lot of cases where you might want to do that. You might want to look up a fact. You might want to have it reference past data when it's writing an email. So like, find the link for me and put it in my email. You might want to do more complex things like write a blog post. I actually did this, our initial blog post for the AI assistant. The outline was actually written by the AI assistant itself. And I actually put that in the blog post, like screenshots of like, I asked it to like search by email for, user feedback and whatever from people I talked to, and like give me an outline of a post that would like answer these questions. But that's kind of the core product feature set. And the way it works is you ask a question. The first thing that we do is we take that question and we try to figure out what data sources do we need to do a good job answering this question. And we have a whole bunch of data sources in the app. We have some of them are available right in the client. So we can look at the thread that you have on the screen. We can look at the threads that you have selected in the inbox. We can look at your settings. We can look at the Shortwave documentation. We can run a search for you. We can include, there's some of the tools that we have are just like extra prompt information to handle like certain use cases really well. So like summarization, if we're summarizing, we like throw in a bunch of extra formatting instructions. But we want to figure out like what are the data sources that we need to put in the prompt to actually answer this question well. And that is just a call to GPT-4 with a prompt. that gives us back sort of an array of like data sources. And then we go off and we load all of those in parallel. And the most interesting and the hardest to build and most capable of those is what we call AI search, which is essentially find all of the emails that are relevant to this conversation. And the way that works is the first thing we have to do is we have to rewrite your query. So when you're asking a question, you may not be phrasing that question in a way that's really easy to do retrieval for. So for example, you might be like, find me emails that are similar to the thread on the screen right now. And if you actually sent that to our backend and attempted to do that search, you're not going to find much. But what you have to do is you have to say, well, what thread is he talking about? What is that about? And so the first thing we do is we take a whole bunch of context, the things that are on the screen, the past history with the conversation that you've been having, other information like that, and we rewrite that. We have an LLM rewrite that into a single standalone question. Be like, what question is this person really asking? Include the various like keywords and phrases and things that will allow us to do retrieval on this. We call that query reformulation. So we get back like a query that now should be fairly self-contained. Then what we do is we try to pull out features from that reformulated query that we could use to do search. So these things might be like date ranges, they might be labels, they might be contacts. We're trying to figure out like, what is this person talking about? What emails might be relevant to this conversation? And the reason we do that is one of the types of searches that we're going to do is an embeddings-based search. But we also want to use our traditional search infrastructure because embeddings-based search is really good if the question that you are asking can be answered with emails that are semantically similar to the question, which is often true, but not always true. But there are other types of questions that can be answered pretty easily with like keyword-based search, or by looking at the specific day that they're talking about, or by looking at the label that they're talking about. And so we actually run a bunch of searches in parallel. One of them is a vector database search that we do with an embedding of a modified version of your question. And the other is like a bunch of searches against our normal search infrastructure to pull out things that based on these different features. And we end up with a big pile of emails. Some of them are semantically similar to the question. Some of them are within the time range that you talked about. Some of them have the same labels. Some of them are with the same contacts, et cetera. And we somehow need to choose from like 1,000 candidate emails which ones we're actually going to feed to the prompt. Because we actually take that whole set. At the time, like GPT-4 just didn't have a context window big enough. But even if it did, it would have been painfully expensive. And even now with GPT-4 Turbo, even if we ignored cost for a second, the response quality tends to drop if you actually pack that context window full. So we're trying to like cut down that set from 1,000 to maybe like 50 or less. That would help us answer that question. And the way we do that is with a cross-encoding model. So we have an open source model that we run on our own GPUs where we take that whole set and we say for each of these documents, we take the question of the document and we say, how likely is this document to help answer the question? And we score all of those and then we sort them and we send the top 50 or so back to the client. And the client takes those emails and the conversation that you've had so far and all the other tools that you've asked for, it shoves all those together into a prompt, sends those off to GPT-4 with some special instructions around formatting. And the sort of last step of this is we get back from GPT-4 your answer markdown formatted with like certain extra sort of decorations on it, like links and things. And we post-process that into the thing that you see in your app that is, formatted nicely and has the buttons in the right places and links and things like that.
I find this really thoughtful for a lot of different reasons. One of the key ones, though, that is sort of cited as a motivation in this developer's blog post I mentioned is that when you all, I think, were probably evaluating different ways that you could go about building this sort of architecture, one of the things that's noted in the post is how lots of other people building this sort of thing are using these long chains of LLM calls. And you kind of have the reasoning sort of broken out into different stages, but that actually kind of creates a lot of problems. There's data loss, there's errors at each stage. And so as you're mentioning, your goal here is actually, of course, context length and what can happen with that being a potential issue, but you're really trying to create what is like a single reasonable length query that includes all contextual information that your LLM can do something with. Do you want to talk a little bit more about that specific part of things?
Yeah, we experimented early on with the various different approaches. And yeah, a lot of people are trying to chain stuff together. And we we just weren't able to make any of that stuff work the way we wanted it to. And we reached the conclusion, which, maybe that has changed, maybe that will change, but we reached the conclusion that we couldn't reasonably chain things together without a significant loss in smarts. And what we needed to do instead was try to answer it with a single LLM call and focus all of our attention on, well, what do we put in that single LLM call? How do we get the most accurate data? So if there's any chaining, it's chaining to get the right data together, but then have a single LLM call answer the end question. And I think that's been a really good approach. I think that's worked really well for us.
Another kind of aspect of this that I found interesting too was the question of, I guess, context. There's a lot of conversation about how much LLMs can like understand about the sorts of questions that we ask and how that relates to the fact that when you and I communicate, we have this shared context. And one of the examples that I think shows up in this blog post is sort of two questions you might ask your assistant. So the first one was something like, what time do I land in this city tomorrow? And then the follow-up question is, what about Johnny? And on its own, what about Johnny just doesn't make sense as a question. But when you put it together with the previous question and then a lot of the other contextual information, again, with access to your inbox, with access to the system time, and all of these other important pieces of information, you can actually take that and make the implicit parts explicit. And I'd love to hear a little bit more about kind of the process for you all of thinking about that.
Yeah, I would say this is a very active area of experimentation for us. I should note. I think it's hard as a normal computer scientist to wrap your brain around the way LLMs work, because with computer science, you're sort of taught that like you want to make systems that are modular and composable, and each system like has inputs and outputs, and you feed the outputs from one to the next system, and it doesn't matter how many of these things you chain together because each one is like perfectly discretely accurate, and this system works. And with AI, it turns out it doesn't work that way, right? Like every component is lossy and not terribly deterministic, and nothing can be like fully modular. And so you have to figure out, how do I modularize-ish this thing without loss of context throughout the whole system? And that's been hard. And I wouldn't say we have all the answers. What we did in this particular case is we do this query reformulation where we have one prompt at the beginning that's like trying to figure out what are they talking about, rewrite into a single query. And I would say that as a V1, that's worked pretty well. Like we can take that particular question and rephrase it to like, when is Johnny's flight? Or, if there's some other information on the screen, and we can include that as well. But I think we can actually go farther here. So like one of the things one of the problems that we haven't solved yet is we do that at the query side. We reformulate in the query side, but you could have an email that talks about Johnny's flight that doesn't actually have the word flight or the word Johnny in it, that references in some other way that we're not going to find because the searches that we're doing are not semantically similar and don't have the right keywords and whatever. And maybe we have to reformulate on the other side. Maybe at the time that we ingest and embed and store, we should be like, for example, like hydrating dates, right? So here's an example. If I say, what did you do last Thursday? It's going to find, not without some smarts, it's not going to find things that happened last Thursday. It's going to find things that talk about doing things last Thursday. And so maybe what we need to do is at the time that we like embed and store is like, we need to convert last Thursday into like a date and then index that. And so short answer is these are hard problems that we're thinking a lot about, and I wouldn't say we have the answers yet.
Before we get a little bit into some of the questions around what's next for this system, I want to at least touch on some of the techniques that were used here to optimize things. I guess, as I mentioned earlier, all of this stuff that we just talked about is being done in 3 to 5 seconds, which I would imagine you want this even faster, but that's already pretty fast given how complex all of this seems. And I know that some of this kind of goes on with when you're doing data retrieval. Some of these things, we talked about modularity, so you can do some of these sorts of fetching different sorts of data from something quite independently, and that's like something you can parallelize, for instance. But I'm wondering if you can talk a little bit more about the opportunities you had to like exploit different performance things here.
Yeah, I think the biggest thing that we're doing on the AI side here is batching and pipelining. So we, we don't wait until we have all of the emails that we might want to look before we start the crosscode. The crosscode is like the big expensive piece. So we actually start feeding email, like we stream them little batch at a time out of Elastic or out of Pinecone, and we stream those into the crosscode as quickly as we can. And we do those in batches to try to optimize use of the GPU. And we have some relatively hefty GPUs, although actually we can probably get some bigger ones at this point. And that is the dominating factor, is the GPU right now. And for what it's worth, 3 to 5 seconds, I'm not happy with it. It's too slow for me. I want to make that faster. And that's, I think, one of the things that's on our list is like, how do we make that like 1 second or 2 seconds? The other big area of optimization is actually, it turns out, in a system like ours, the non-AI things can, or the non-cross-locator things can actually add up too, because there's a lot of pieces going on. So we have the tool selection that I mentioned. There's the query reformulation. There's the feature extraction. And we try to parallelize a bunch of that stuff. We try to use faster, smaller models for some of that stuff. And then there's also just the normal search infrastructure and data loading. It turned out actually one of our big problems with performance early on was just loading things out of Elastic, which you'd think would be faster than it was. But like, when you load 1,000 email threads, like, it's actually kind of a lot of data. And so we try to do a bunch of clever stuff to like only load just the pieces that we need and be much more clever about that. So I would say it's mostly not AI magic. It's just a lot of, careful systems engineering and pipelining and parallelization and thought. And I hope that we can cut it down a lot over the next, 6 months.
Yeah, so you were mentioning before we started recording that there are going to be some fairly big changes coming to the AI assistant. I'm wondering if you could talk a little bit more about what's currently, I guess, in mind for the evolution of this.
Yeah, the thing that's really fun about this job is the AI stuff is moving so fast that we put that blog post out in October, and it's all obsolete at this point. Like every I can point to every paragraph in there and be like, oh yeah, we're gonna do it this way now, and across the board. And so actually, for those of you, if you ever share the video, like, this is just like all of the ideas that we have for improving that system. We were just talking about this the other day, but I can go through some of these. So a bunch of stuff has changed since then. One thing that's changed is the embedding models have just gotten better. So we were using or are using an open source one that we just grab off Hugging Face. There's better models out there. Another thing that's changed is the vector databases are able to more cheaply handle large vectors. So a big issue for us is people have a lot of emails. So like, my personal email inbox has 3 million emails in it. And if you're trying to provide a service like ours at a reasonable price point, just the storage in the vector database can start to be quite expensive. And we use Pinecone, and until recently, we had to be really careful about that. And it's been a dominant, big piece of our cost has been what we do with Pinecone. But they have a hosted service now that allows you to separate compute and storage, and allows for a use case like ours, where it's like a ton of storage and relatively light querying in comparison. It allows us to separate those out and save costs considerably. And what that lets us do is use bigger vectors. So we intentionally did not use an embedding model that had like a big vector because it had too much storage cost. We used a smaller one that was, kind of dumber for cost reasons. But that may be changing. So maybe we can use a bigger embedding model, and we can use a hosted Pinecone or like one of these other cheaper vector database solutions, and actually store the bigger vector and do much smarter searches. So I think that's one big area. There's also other approaches that we've been looking at for cross-encoding, and I don't think I have anything smart to say there, because it's all like very early exploration phase. But there's like other techniques that people have been looking at. There might be like better models that we can look at, but like the re-ranking phase can probably get much smarter. The LLMs as well have gotten much bigger context sizes, and there's more options. So when we did this in the fall, like, it was all GPT-4 Turbo, or sorry, GPT-4, and it had GPT-4 was slow, and it had context limits, window limits, and it was expensive. And we now have we're running Mistral in production for some other features, and fine-tuned Mistral can do a lot of the types of things we want to do, and it can do it way faster. So for certain types of like internal use cases, things like query reformulation and feature extraction that we were doing before with GPT-4, like, we can maybe now do these with Mistral. And then for the final response, we have GPT-4 Turbo, which is not only faster and cheaper, but it gives you a much bigger context window. So in previous cases where like maybe it didn't answer your question well because it could only consider 50 emails, maybe we can stuff 100 emails now in there, 200 emails in there, and give you a better answer. And there's a long list of other kind of smaller things, but like the LLMs, the embedding models, the techniques for re-ranking, the vector databases, they're all better, they're nicer, they're faster, they're cheaper, just in a few short months. And so we're going to be rebuilding all of that.
One of the things we were talking about a little bit earlier too that I'm wondering if you have thoughts on going forward is with the kind of final step of we've now sort of crafted this prompt that is all the information we need, and it's probably a pretty long prompt that we're going to send to GPT-4 Turbo. And with that very large context length, well, in kind of the limiting case that I think is also mentioned on the blog post where you have like an infinite length context window, very long prompt and all of this and everything can kind of work out perfectly and you have perfect reasoning and all of this, then you have like exactly what you want. But again, there are the limitations we have right now. And one of the things that we were talking about earlier was this kind of lost in the middle effect that I think researchers have looked into, where you bloat the context enough and some of that information is going to get kind of lost with respect to whether the LLM can actually make use of it. I'm wondering to what extent you've been I know you've already been kind of innovating around how to actually deal with this issue and like make sure your prompts aren't too long, but I'm wondering kind of what that particular issue looks like for you going forward. Is that still something that you're struggling with a little bit? Like what kind of thoughts do you have on that?
Yeah, we definitely have run into that, and we've experimented with shoving more data in there, and it definitely does seem like that is a real effect. The honest truth is, right now, cost is actually a more dominating factor for us. So the upper limit for us isn't actually that loss in the middle effect issue. It is just too expensive to be shoving 60,000 tokens or something into every prompt that we do. So hopefully that'll change. Hopefully the prices will keep going down, and then maybe this will become the dominating factor. But at any given point, like it's sometimes this is the smart, sometimes it's the latency, sometimes it's the cost that's dominating. And right now, cost is the dominant thing for us.
I think the last thing I want to talk about here, and this could maybe look like advice, I guess, for other builders and people who want to do things that are kind of similar to this, is I was reading your 2023 year end review, and you also had an AI launch week recently where you were just shipping thing after thing. But with the 2023 wrapped, and I'm reading the stats here, your team launched 117 new features. You merged 4,638 PRs and made 817 fixes and improvements. And given the size of your team, those are some absolutely wild numbers. And I'm wondering if I can get you to talk a little bit about your methodology for iterating and like shipping stuff fast.
Yeah, I wrote a whole series of tweet storms on this the week before AI launch week. I don't know if I'm allowed to call them tweet storms anymore, but X storms or whatever. And I think this is something. This is something I really take pride in. I think our team, we may not be product geniuses, we're not ML experts necessarily, although maybe we will become, but we ship fast. And that allows us to learn really quickly, both technically and on the product side from rapid iteration. And the whole company is kind of optimized around this. And there's a bunch of stuff that we do. So one of the things we do is we have an experiments framework where we are constantly pushing to prod. And new code, when it gets written, it doesn't sit in some branch for a long time and like take a bunch of it goes to prod right away. And like 5 times a day, if you use the product, every time it has an update button show up at the top, like there's been a new code push. And we actually had to make it so it only shows that update button a certain number of times per day because it was getting annoying for people to see like so many code pushes. So like we don't always even prompt you to upgrade anymore. But the way we do that is if you go to the experiments page in settings, you'll see some of the stuff that's available to you. And internally, and for some of our alpha groups, there's a much longer list. And like we actually, I think before AI launch, we had 44 different experiments running at any given time. So each person, they're pushing code. That code isn't gated by some release process. That code is gated by the experiments live in the product that allows us to basically like test and get feedback on things much more quickly and to like not have like monster merges that we have to deal with that are like very high risk. So I think experiments is one big part of that. I think another thing is just like a lot of investment in our development environment. We put a lot of work into making sure that like it is one command to start the whole system on your local machine, including, for example, making the AI search stuff work. We find a way, we have a, local vector database thing, even though our one in the cloud is a hosted service, and we find a way to mock out the LLMs and stuff. So it's one command gets the whole thing running on your machine, and it's a lot of work to do that, but we use Bazel, we use Kubernetes to make sure that everyone is able to evolve together on the local machine and run the whole thing locally. There's also just a lot of process that we've sort of streamlined around how this stuff all works. And then we have a team that's, I think, values speed, and we hire for speed, and I drink a lot of coffee, so that helps.
Yeah. Well, I think this is really a good summary. And I guess maybe as a last question, we've already talked a little bit about some of the AI features, improvements, cost reductions that are going to make a big difference for Shortwave. I guess accepting what's going to be useful for business. Is there anything that you're kind of following that you're particularly excited about on the horizon?
Yeah, I can give you some broad areas here. So I think I'm very excited about anything that makes a RAG stack more capable and faster and cheaper. So I mentioned vector databases being able to store much larger amounts of data much more cheaply, and that's been coming. I think that's going to continue, which is going to let you have bigger embeddings and use them for a lot more stuff much more cost effectively. Same time, better cross encoding models. I think that will help a lot. Obviously, smarter LLMs. So I think in our experience, everything before GPT-4 couldn't reason. I know we can talk about whether it was reasoning or not, but couldn't reason about the things we needed to do. If we needed to make decisions around how to act, of what to do next, we really couldn't get any other LLM to do it except for GPT-4. And now I think there are maybe some new models that are close, and they're definitely within a year are going to be more models that can do this. And hopefully, when GPT-5 or whatever comes out, it won't be just barely over that reasoning threshold. Maybe it'll be well over that reasoning threshold, and we can ask it to do more complex things. So I think just smarter reasoning in the LLMs would be great. Cost reduction. Very excited about cost reduction. That's a huge limiting factor for us. In every feature we release, this is a major bottleneck for us, and we're always looking for ways to kind of constrain those costs. Multimodal, I think, will be interesting, especially finding ways. We don't do anything with multimodal right now, but I would love to start thinking about what does that look like in email, right? Are we going to start feeding your attachments into it? Are we going to make it so that when you want to interact with the assistant, you can do it over video? Maybe on your phone, you actually just video chat with an avatar, and it can see you, and it can use your expressions, and you can use your hand motions or whatever. So yeah, lots of stuff coming, lots of stuff I'm excited about.
Well, I think this is a really good place for us to come to a close here. So Andrew, thank you so much for, your team is really open about a lot of the techniques you're using, and I feel like a lot of people are going to learn from what you're doing. But I also think that the product you're building is really, really exciting. I think that more people should be paying attention to this kind of stuff, and I hope that more people will pay attention to your team's journey.
Thank you so much for having me. This was a lot of fun.
That's it. That's the whole episode. Thank you for listening. If you like this, really the best thing you can do is to leave me a review and to share this episode with someone who might find it interesting. You can also subscribe to the podcast in your favorite podcast player, and if you want to keep up to date with the latest from The Gradient, to receive emails whenever we have new podcasts, newsletters, articles, then you can subscribe to us on Substack, where you'll get email notifications for everything.